here we have a perimeter area optimization problem, and I had to say it's one of the more easier optimization problems to understand. So let's get to it. So it says find the dimensions of a rectangle with a perimeter of 20 units, right, and maximize its area. Okay, so first things first, I'm going to actually find the formula of the perimeter of a rectangle is basically going to be equal to 2x plus 2y. I can easily see that. See x and x, y and y. Add this together, you're going to get 2x plus 2y. Alrighty, and they say our perimeter is 20 units, so we can just plug in for our p. You can do 20 is equal to 2x plus 2y. Now we can simplify this even further by dividing everything by 2, right? You can divide this by 2, divide this by 2, and divide this by 2. You're going to get 10 is equal to x plus y. Alright, so I usually like to think of this as, my first equation, right? My first little equation here, and we can manipulate this in many ways. What I really want to do is I want to actually write this in terms of one singular variable, right? I want to write my y in terms of x, right? Because I don't want two variables in any equation because it's really confusing and difficult to solve. So let's do this. So this is going to become, make this a different color, it's going to become 10 minus x is equal to y. So whenever I have a value of y, right, I'm just going to put 10 minus x into it. Now, for our second equation, let me just put this in red because it's more easier to see, right? So for our second equation, what's to understand is this, is that our area, right, area of any rectangle is going to be x times y. Now, this is where this comes in really important, right, when we're simplifying this. Because now we can write our y in terms of our x here, okay? So let's do this. So our area is going to be equal to x, which I'm just going to keep as x, and y is going to be 10 minus x. Now I'm going to use distributive property to simplify it. So it's going to be equal to 10x minus x squared. Now our next part of solving this problem is to actually find our critical points. In order to do that, I'm going to take the derivative of a here and then set it to 0. So let's do this. So a prime of x is going to be equal to, we're going to take the derivative of 10x, which is just 10, and x squared, which is going to be just 2x. Alright, so now from the derivative, we're going to set it to 0. So we're going to do 10 minus 2x is equal to 0. Isolate for x here. So negative 2x is equal to negative 10. X is going to be equal to negative 10 over negative 2. So therefore, our x value here is going to be equal to 5. Now, something really important about these optimization problems is to actually check if it actually is our maximum. In order to do that, I'm going to be taking the second derivative of a. So let's do that. So if my a prime, I'll show you, so if my a prime x is going to be equal to 10 minus 2x, then my second derivative is going to be equal to negative 2. Now you have to understand that if we're going to be looking for a maximum, right, our graph needs to be concave down. And if our second derivative is less than 0, sorry, way around like this, if it's less than 0, then it is basically concave down. And we know that negative 2 is indeed less than 0, so this is indeed concave down. Alright, so now since we found our x value, the rest is really simple. All we're going to have to do is just plug our x value of 5 into this equation over here, right, to get our y value. And we can just do it here. So y is going to be equal to 10 minus x, right? Y is equal to 10 minus x. So y is going to be equal to 10 minus 5, and which is then equal to a value of 5. So my x and y values are 5 and 5. So x is equal to 5, y is equal to 5. And now to get the dimensions of rectangle maximized area, so max area is going to be equal to, so I'm just going to put area max is going to be equal to 5 times 5, which is equal to 25 units square. So it's square units, right? So yeah, so we found our dimensions, we found our maximum area. So that's basically how you can approach a optimization problem involving a perimeter and area. And specifically for a rectangle. Hope it helped. Have a great day.